So this is gonna be first assignment of the 9 weeks. So number one thing I want you guys to understand is that you need to know how to solve and how to add, subtract, multiply imaginary numbers. So today we're actually gonna go ahead and we're gonna be working with imaginary numbers. Now this doesn't really, you don't see it as often, but it is important to understand that sometimes you're gonna have numbers that are not real, and I'm gonna show you right now different things. So in order to start understanding what imaginary numbers, we need to understand what real numbers are. So you see right here I have a whole chart, and I'm gonna fill it up. I'm gonna be putting stuff in them. So to begin with, we're gonna start with natural numbers. So we're gonna have, that's the lowest of the low. That's the simplest type of number that you're gonna have. Now natural numbers start from 1, 2, 3, 4, 5, and it's gonna go. Now whole numbers is gonna start adding a couple things. So when we have whole numbers, we're actually gonna go ahead and we're gonna be adding 0. And same thing, you're gonna keep going. Now integers, now that's when we start introducing negatives. So we're gonna start with -1, 0, 1, 2, 3, 4, and it goes forever, but this time it goes forever on both sides, right? It's gonna go forever on the negative side, it's gonna go forever on the positive side. So that's the first 3 types of numbers. So natural numbers, 1 to infinity. Whole numbers starts from 0 up. Integers, we start implementing zeros. Now rational numbers and irrational numbers are going to be slightly different. Now rational numbers is going to be a decimal. Oh my god, I'm trying to move this thing. It's not letting. Okay, so oh my god, there we go. Rational numbers, this is going to be very, very unique. So when it comes to rational numbers, you're either going to have a fraction like this, 1/2, or you're going to have a decimal. And those are 2 different types of rational numbers. Also, another rational number would be something that's continuous. For example, you get 0.233, and then you have a line like that. That means that that decimal is going to keep repeating forever. So if you have that, that's also a rational number. So anything that you can think decimal that repeats or fraction is actually going to be considered a rational number. Now, irrational numbers are numbers that never end. So this one never ends. And I'm already going to tell you, a irrational number is going to be pi. And sometimes it's going to be something like this. Square root of 7 might be an irrational number. Square roots I'll also consider rational numbers in most cases, but usually focus on pi. Pi is going to keep going. It's like 3.14, and it keeps going forever. Never repeats or anything. So that's an irrational number. Now, real numbers is going to be everything combination. So all of that put together, that's going to be considered a real number. Now, final thing that we have to focus on is imaginary number, right? Because we have real numbers and we have imaginary numbers. Imaginary numbers is literally just a number that has a number in front of it. No. An imaginary number is basically a number that has an I next to it. So like 2i, you can have 5i, you can have 6i. Alright, so that's basically an imaginary number. Anything that includes I. Now finally, complex number is going to be a combination of a real number and an imaginary number. So it's going to look something like that. I'm going to put in parentheses. And you always want to put the real number first. So I'm going to go ahead and put like 5. Then I'm going to put plus 2i. And that's it. That's a complex number. That's the highest of the chart number. That's going to be the one thing that includes everything below it. Okay. So we're going to go ahead and skip a couple things. I'm going to go over a couple things. So you're going to see I have a whole bunch of numbers right here. And it's telling me to describe every single number. Okay. So right here, I know the very first number, 3. I know that's a natural number, right? Natural number. I know it's also a whole number. You can use the notation they give you, but I'm just trying to do this as fast as possible. You also have integer, right? Then that also includes a real number, so I'm going to put real number. And it can also be a complex number in a complex number. So it has all of those different categories. Now the square root of 7 is just going to be irrational. Irrational number, and it's also going to be a real number. I don't know why you wrote the whole thing. And finally, it's going to be a complex number. Alright, that's basically categorizing everything. But right now, we're not going to worry about it, because the assignment that you're going to be doing today, we're just going to focus on this section right here. So I want you to focus on this. So we already know that imaginary numbers exist. How do we get them? The number one way that you can always get an imaginary number is by having a negative inside of a square root. You can never have a negative inside of a square root. If you plug it in your calculator, it's going to give you an error. So, if it's going to give an error, how am I supposed to deal with the number that's negative inside of square root? Well, the answer is pretty easy. All you have to do is turn that number into an imaginary number. I'm not going to show you guys right now how to actually do that. So to begin with, you're going to look at the number. You're going to notice that it's going to be inside of square root. So what I'm going to do, I'm going to go ahead and write the number, but instead, I'm going to make it positive. Okay? Now, once I make it positive, this is very important, and I'm going to show you right here. I mean, it's going to tell you on the top that negative I times... Okay, so let me rewrite all of that again. The square root of negative 1 is equal to I. Now, I was explaining that to a lot of people, but I'm going to make it a lot simpler for anybody watching this. So whenever you have something inside of the square root, first thing that I want you guys to do, we cannot have a negative, so I'm going to turn it into positive. Plain simple. Now, all I want you guys to do after that point is go ahead and find the square root of that number. Now, what is going to be the square root of 4? I know the square root of 4 is 2. But 2 is a real number. How do we make a real number into an imaginary number? Because that's what we have to do. Well, what do you think? I'm just going to put an I right next to it. So that's literally all that you need to do for all of these problems. And let me grab my calculator, because sometimes you're actually going to have to go ahead and plug it into a calculator that has the square root. Let me see. I think I have a calculator real quick. The reason why you need a calculator is because you're not dividing. Square root has its own property and it uses its own rules. So the easiest way to do this is just plug it into the calculator. I don't want you guys to really worry about it. We're not going to worry about simplifying the radical or the square root in this case. We're going to do that later. For right now, I just want you guys to get used to just finding the square root of anything using a calculator. So for the second one, I'm going to do the same thing. I have the square root of negative 12. Again, can I have a negative in front of or a negative inside of my square root? No, I cannot. So I'm going to turn it into a positive. Now I have to find the square root of 12. So if I use my calculator, put square root of 12, I am gonna get 3 point, and I'm only gonna put 2 decimal places just so I'm not even gonna round, just 2 decimal places. Now that's what I get. That's the square root of 12. Now what do I do with that? Well, once I have that, I have to turn that into an imaginary number, which all I have to do is just add I to it. That's it. Now let's do another number. Now this is going to be a complex number. As you can see, I have a real number and I have a number that's not real. So I'm going to leave the real number alone and I'm going to worry about that later. What I'm going to worry about first is turning that negative 50 into an imaginary number. So again, I turn it into positive and then I just have to find the square root of 50. So the square root of 50 is going to be 7.07. Now, how do I turn that into an imaginary number? You guessed it, we're just going to put an I. So that's one part of my answer. Now I have to put both my real and my imaginary number put together. So I'm going to put 5 plus 7.071 or I, and that's my answer. Now let's go ahead and do the last one. Now for this one, some people might get confused. It's actually pretty easy. I'm going to separate this whole thing into two different fractions. So I'm going to do 6 over 2 minus the negative, or the square root of negative 8 over 2. Alright, that's my problem. So I'm going to start simplifying stuff. I know 6 divided by 2 is 3, so I have 3 minus the square root of negative 8 over 2. Now I'm going to have to simplify the top because we cannot have a negative inside of a square root. So again, square root of 8, which is square root of 8, it's going to be 2.82. Okay, now in order to turn it into imaginary number, I need to put I right next to it. So there we go. Now we're going to write our answer. So 3 minus 2.8 2i over 2. And I'm just going to leave it like that because I cannot divide that 2 because the 2 is a real number, but the number on the top is imaginary, so I cannot combine it. So I'm just going to leave my answer like that. So that's it. It's a complex number, so we're just going to leave it like that. I know I'm going through a lot of this stuff really quick. It's because I'm trying to make this video so fast so you guys don't get bored. Watch it quickly and understand what's going on. Now, also on the paper that I'm going to give you, there's 2 more things that we're going to go over. We're going to go over adding, subtracting imaginary numbers, also multiplying. And then we're going to focus on how to plug them into a graph. So right now we're going to have a graph and we're going to be plugging in. I want you guys to focus on something. My y value, so up and down, is for imaginary numbers, so I numbers. Okay, my real numbers are going to be horizontal, and those are going to be real numbers. You can even see it right there. It says real right here, and it says imaginary over here on the top. Alright, the way that you plug them in, you just look at the point that they give you. For example, I'm going to do the very first one. So if you look at A, it says I have to go to 5. 5 is going to be on my x-axis, is positive, so I'm going to go right here where 5 is. I'm going to erase that in a bit. And then from there, I have to pick my second number. Okay? Which is negative 3i. So I just have to go down 1, 2, 3, and that's where my point is going to be at. So I'm going to go ahead and erase the first point I did, because I don't care about that one. I care where I'm actually going to end up in. So I know I'm going to go 5, and I'm going to show you by doing a different color. So I know I start from the origin, 1, 2, 3, 4, 5, and then negative 3i, 1, 2, 3, and that's why I end up right there. So that's literally all you have to do whenever it comes to plug in this point sense. And it's going to be really easy on the handout. Literally, that's all you have to do. Let me do another one. Going to do the second one. Alright, I'm going to do a different color just so you know where I'm putting it. So it's going to be negative 3. And then I'm going to go to positive 4. There you go. Now I'm going to do one more. I'm going to do C. 8. So 8. Right there, right? And then plus 6. So we're going to go up. All the way up right here. Boom. Those are my 3 points. Okay? Now, on the worksheet, you're going to have to do your own points. But that's it. That's literally all there is to it whenever you're plugging in your imaginary or complex numbers. Because these are complex numbers. Complex numbers. And the reason why is because you have a real number and you have a imaginary. I'm going to put M number. You have both of them together. That's why we call them complex numbers. Now, some of them are just like literally, like this is an imaginary number. I am. And this is just a regular number. This is a real number. So all you got to do, you just got to go one direction and put your dot. Okay? It's almost like if this is your X and this is your Y. Literally, that's our coordinates for whenever you plugging in imaginary numbers into a graph. Okay? We're going to go to the final thing. and then you're gonna have to go ahead and do everything else. All right. So I'm gonna focus on B because a lot of people have trouble with B, and then I'm gonna focus on C, and then I'm gonna focus on A last. Okay. Actually, I might do it the other way around. I'm gonna do this one first. Okay, you know what? Let's just start with A. Now, whenever you have a problem like A, first thing I want you guys to do is understand which ones are your imaginary numbers and which ones are your real numbers. So I can already see, just by looking at my numbers, that 3 and 1 are going to be real numbers, and that my imaginary numbers are going to be 2 and -6. Now, you see this negative right here, right? That's very important. That negative is going to be doing a lot of stuff. So the thing is that it's going to distribute to here, and it's going to distribute that. So that's basically going to change my entire problem. So I'm going to work with that first. If you have anything, if you have parentheses and you have a negative next to it, like here, like we do here, then you're going to do the following. Let me erase all this nonsense. All right, here we go. I'm going to rewrite my problem. So let's go make this black. So I'm going to rewrite the first, it's like 3 plus 2i. Let me make this skinnier because, my goodness, it's not really working right now. Okay, so 3 plus 2i. Now, this is a positive 1, so whenever I actually distribute the negative, it's going to become -1. And then this guy is going to become plus 6i. Now we have everything we need. Now we can solve the problem. I want you guys to go ahead and put your real numbers together, and then you're going to put your imaginary numbers together. So I'm going to do 3, then -1, which is basically -1, so that becomes 2. Now we're going to do the other one. So we're going to do 2i plus 6i is equal to 8i. Now we have both of my answers. All I have to do is write my complex number, which means I need to put my real number first and then my imaginary number second. So it's going to be 2 plus 8i. And that's my answer. You're going to have to do that in the worksheet that I'm going to be posting, so make sure you follow these rules. Now, B, same thing. Now, this one's easier because I don't have to move anything. I don't have to distribute a negative like I did over here. You see the negative right there? I had to distribute it. This time, I don't have to distribute anything, so I just need to write my real numbers, and then I have to write my imaginary numbers. So my real numbers are going to be 3 minus 6 minus 1, and whatever that equals to. So I know that if I combine all of that, I'm going to get -7, then +3, then that's -4. All right, that's my answer for the first one. Now the second one, I'm going to underline them just so you can see. Those are my real numbers, and those are my imaginary. All I'm going to do is 4i plus I is equal to 5i. At this point, I have both of my answers. All I have to do is write my complex number. So real number goes first. Imaginary number goes second. Easy peasy. It's that easy. It's really straightforward. It's not very hard. Now the last one. And I'm just going to show you how to do D. I'm not actually going to do it just to save time on this video, because it's already 20 minutes long, and I don't think you're going to watch the entire 20 minutes unless you're really focusing on this. Now, for this one, I'm going to have to get this 5i, and I'm going to distribute it to the 3 and the 2. Exactly the same thing that we did with the negative. We're going to multiply that to the 3 and the -2. So I'm going to write my problem. So I know I'm going to have 5i times +3. I almost made a mistake there. And then on the bottom, I'm going to have 5i times -2i. Okay, all I have to do at this point is just write my answer. So what is 5i times 3? That's going to be 15i. Now, what is 5i times negative 2i? Well, I'm going to have a negative 10, right? First of all. And then I'm going to have I, but now this time it's going to be to the second power. And now, this is funny, because I want you to look what it says right here. It says the value of I squared is equal to negative 1. So, I'm not done with my answer. So this guy right here, I actually have to simplify. The way that I simplify, I'm going to write it out again. But I'm going to put parentheses where the I squared used to be, and I'm going to put negative 1. Because all I'm going to do is substitute I squared with negative 1, because that's what it says I need to do here. Now, once I do that, you're going to notice that I'm going to get a real number, and I'm going to get, my real number is going to be 10. Okay? Now, I'm finally done. I have my two numbers. I'm going to put my real number first, so it's 10 plus 15i. Are we good? And that is my answer. Okay, it's a lot of work. Hopefully you've been following everything. You can stop the video anytime that you want. Now the final thing I'm going to go over is how to do D. I'm just going to explain how to do it, and I'm actually not going to do it. You see what we did over here with this problem? I'm going to do the same thing. So I'm going to distribute this guy here, and I'm going to multiply this one with this guy over here. Boom. And then I'm going to do it with the second number. I'm going to grab this guy, multiply with this, and this guy, multiply with this. Once I finish doing that, I'm just going to simplify everything. Change any I squares to negative 1, and that's going to be my answer.